feel the vibe.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with basic sequences and series. Today we are going to focus on the recursive sequences and factorial notation. So as we talked about in the previous video, sequences are a series of numbers in a specific order. Now, we looked at a formula for how to find a generic term. There's also a formula that can be found called a recursive formula. What the recursive formula does is it tells us how to find a new term based on the previous terms. So before we just had a formula and we put in 1 for the first term, 2 for the second term, 3 for the third term. And we went so on and so forth until we found all the terms that we needed to find. But for a recursive formula, we're going to use previous terms and substitute those in. So in problem 3, it says write out the first 8 terms of the recursive or Fibonacci sequence, defined by C1 equals 1, C sub 2 equals 1, and C sub n equals C sub n minus 1 plus C sub n minus 2. So this sequence is a very famous sequence created by Fibonacci himself, and it has some applications that you guys will learn about in the future. But for right now, we're just focused on using this recursive formula to find the first 8 terms. So the first term was given to us. C sub 1 is 1. The second term was not given to us. C sub 2, or sorry, was given to us. C sub 2 is also 1. The third term was not given to us, but what it can be found is by using this formula. So C sub n minus 1 means the term that comes right before n. So if we're looking for the third term, the term that came right before is the second term, plus C sub n minus 2 means the term that came 2 times before n. So if we're looking for the third term, 2 times before n would be the first term. So in order to find the third term, we would do the second term, 1, plus the first term, 1, and that is 2. And we're going to continue this pattern. So C sub 4, the fourth term, would be found by taking the term previous, C sub 3, or 4 minus 1, plus 2 terms before, C sub 2, or 4 minus 2. So the third term was 2, the second term was 1, so then the fourth term is 2 plus 1, which is 3. We need to find 8 terms here, so the fifth term would be C sub 5 minus 1, or the fourth term, plus C sub 5 minus 2, again following that explanation there, the third term. The fourth term is 3. The third term is 2. So 3 plus 2 is 5. We can keep this pattern up. So the sixth term would be the fifth one, plus the fourth term. The fifth term is 5. The fourth term is 3. And 5 plus 3 is 8. Let's continue. C sub 7, the seventh term would be the sixth term, plus the fifth term. The sixth term is 8. The fifth term is 5. 8 plus 5 is 13. See if you can find the 8th term. So the 8th term, if you have found it by now, would be the 7th term plus the 6th term. The 7th term was 13. The 6th term was 8. So the 8th term is 21. And so the first 8 terms of C sub n, or of this sequence, would be 1, 1, 2, 3, 5, 8, 13, and 21. And then we can continue. So this set, essentially here, would be the first 8 terms of our sequence. And you could go on and find more if you would like to. So recursive formulas give us new terms based on previous terms. Now, there are some other things that come into recursive formulas in other versions of sequences and series, known as factorials. And so you may have seen this button on your calculator before, the factorial button. And the factorial button in math is just an exclamation point. And what this means is that we take if we have n factorial, this is how you say this, n factorial. This would be the nth term times the term that came before, times the term that came before, times the term that came before, all the way down to 1. So let me give you an example with numbers here. So if we have, let's say we have 5 factorial. So 5 factorial would equal 5 times 4 times 3 times 2 times 1. And so we could evaluate this in the calculator. 5 times 4 times 3 times 2 times 1. And it's 120. So for factorials, you multiply together all of the numbers from our given number down to 1. Now, in problem number 9, it says simplify each of the following by writing the numerator in an equivalent form. So what we see here in 4 is 9 factorial. So 9 could be written as, 9 factorial could be written as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we could rewrite that number. However, the denominator is 7 factorial. So what we see right here, if I section off this part right there, this is actually 7 factorial. So that is 7 times 6 times 5 times 4 times 3 times 2 times 1, which means the same thing. So what I'm actually going to do is I'm going to rewrite the numerator as 9 times 8 times 7 factorial, and then stop there and write the denominator as 7 factorial. Now, if we know anything about fractions, or rational expressions, as we have talked about earlier this year, 2 factors in the numerator and the denominator, if they are identical, eliminate each other. And so this would be the same as 9 times 8, which is 72. So what we can do here is we can rewrite the numerator to match the denominator as factors and simplify, and then be able to evaluate a more simple expression. Let's take a look at problem number 11. In problem number 11, I can rewrite this numerator as 11 times 10 times 9 times 8, and then factorial. The reason I'm stopping at 8 factorial, I could go all the way down to 1, but you see in the denominator, I have another 8 factorial. So I can eliminate here. So I have 11 times 10 times 9 over 2 factorial. Now 2 factorial would be 2 times 1, or just 2. So I can simplify again here. I could just write this denominator as 2, and then take 10 divided by 2 and make that 5. And so in my numerator, I have 11 times 5 times 9, which is 495. Go ahead and pause the video and see if you can do C. Hopefully you've had a chance here to find an answer for C. There's a couple different ways that we may go about doing this, but I'm going to go ahead and write 6 factorial as 6 times 5 factorial. And now, if I compare my numerator to my denominator, I see the 5 factorials cancel out. Now, some of you may have written from 6 down to 3 factorial and then canceled out the 3 factorial. That would have been okay. But what I can see here now is the numerator is 6 over 3 times 2 times 1, which is the same as 6 over 6. So this expression is just 1. So this is one way that we can evaluate factorials, doing arithmetic and simplifying expressions. You can also do this in the calculator. So if I go to my calculator, let's take a look at A, and I do 9, and I hit the catalog button, or sorry, let's actually use the math key, and go over to probability. The 4th option down is the factorial button. So 9 factorial divided by 7 factorial gives me my answer, 72. For B, I need to probably be a little more careful here when I type this in. Same thing, let's do 11, then hit math, go over to probability, take that factorial, 11 factorial divided by, I'm going to go ahead and either use the fraction button in your calculator or put parentheses around 8 factorial times 2 factorial to make sure that your calculator does the correct order of operations that you intend. So we can see here that that's 495. Now, if I were not to have the parentheses there, let's go ahead and pull those parentheses out, and you can see that it's going to actually take divided by 8 factorial and then times by 2 factorial, not the correct answer. So if you use the calculator to input these as well, which we will in the future, be careful with your input method. Now, let's go ahead and take a look at factorials in sequences. So in problem 5, it says find the third term of each of the sequence listed below. So let's do this by hand and then use the calculator. A sub n, if we want the third term, we're finding a sub 3. So I'm going to replace my n's with 3's. So 3 factorial over 2 to the third power. So a quick substitution there. If I wanted to, I could do 3 times 2 times 1 in the numerator over 2 to the third power, which is 8, and get 6 over 8, which simplifies to 3/4. So the third term here is 3/4. You could also do this in the calculator. 3, hit math, go over to probability, select the factorial button, and then do 2 to the third power. And there we have 0.75, which is also 3/4. See if you can pause the video and complete 5B. Hopefully you've had a chance to do 5B. So we're finding the third term here. It says c to the nth power, which is the same notation, just using a different variable for the term. So we want the third term, which would be -1 to the third power, times 2 times 3 minus 1 factorial, all over 3 factorial. So you can simplify this if you wanted to. -1 to the third would be -1 times -1 times -1, which should just be -1. Inside the parentheses, I would have 2 times 3, which is 6 minus 1, so 5 factorial over 3 factorial. And if you want to go a little bit further by hand, that would be okay. Let me just go ahead and use the graphing calculator at this point to evaluate my factorials. And we should get the value, -20. So here we have the ability to continue finding terms of a sequence, but also throwing in factorials and recursive sequences. This looks like a good place to stop. As always, thank you guys for tuning in, and I'll see you soon.